Pascal's triangle has a whole bunch of properties. Very, very interesting properties. Far more than I'm going to talk about briefly today. By the way, it's worth noting, Pascal was not the guy who invented this triangle. He's not even the first guy to have spotted the pattern. Like, it was, you can find it in all kinds of mathematical literature going back centuries. But Pascal did a lot of work with it, and it's not just because he has a cool first name that it got named after him. It's largely owing to him. Like, come on, who names their kid Blaise? I'm gonna call my kid those crazy French people. Anyway, so Blaise Pascal and his triangle. Let's notice some things about it. Okay, let's notice some things. For instance, what makes Pascal's triangle Pascal's triangle? How is it constructed? This is the first property. Like, actually, where do the numbers come from? They come from addition, right? In fact, the first and most important property is called the addition property, right? Now, I'm not gonna write it out at length on the board because it would take me a while, but I think you can see what it's getting at, right? With the exception of the first one, right? And actually, if you put a different number up there as your starting point, your seed, if you like, you end up with a whole different thing. But anyway, each number is composed of the two numbers immediately above it, right? On its left and in its right. And in these cases, there's no number on the left, so that's functionally at 0, right? Which is why it ends up as 1s. So the addition property is what makes Pascal's triangle, okay? But there are other important things to note, okay? For instance, if you have a look at the diagonals, and you guys have done this before, right? When you were just wee little people, the diagonals have properties, okay? So, I mean, an obvious one, if you take the second diagonal, okay, what are those numbers? What are those numbers? They're the counting numbers, or the natural numbers, or the set of positive integers, right? So you have a pattern there, right? But that's not the only pattern. For instance, if you take the next diagonal, this one is a little harder to recognize. Does anyone recognize what 1, 3, 6, 10, 15, and so on are? Those guys, they're the triangular numbers. Do you remember the triangular numbers? Look, I'll show you. Here's 1, right? Now if I make a triangle, here's 1, 2, 3, okay? And here's 1, 2, 3, 4, 5, 6, and I could keep going, okay? Now there's obvious reasons why this diagonal gives you the triangular numbers, right? Can you see? It's because the triangular numbers are constructed in the same way that Pascal's triangle is constructed, right? Not a coincidence. I wonder if you recognize what the fourth diagonal is. I'll let you have a think about it. So number 2, the diagonals, they are important sets. Those numbers, they're all connected. Every single one. Okay? There's other interesting things about it. I've given you a couple. Can you give me some? What other kinds of properties can you see? I can see at least 2 more. Probably more, but what ones can you point out? I mean, some are obvious, right? Sorry, say it again for me.
When you add 2 numbers in the same row and you go down, ready? Equal to that.
Wait, that's this one though, isn't it?
Oh.
Yeah. Hands up if you missed me explaining what the first property was. Yeah, so the addition property, it actually, by the way, it feeds down further than just 1 row to the next, right? You can talk about like 2 rows difference and you can see that there are patterns there as well, okay, obviously. And an obvious one, it's symmetrical, right? It's symmetrical. It has line symmetry. Each row is reversible. That's very important. You'll see why later on. Okay. We've looked at the numbers and how they relate to each other, right? But if you have a look at the numbers and you add them up in different ways, not just in the way that the addition property suggests, right? You get different things again, okay? For example, okay, the first row. What is the sum of all the numbers in the first row? It's 1. What is the sum of all the numbers in the second row? It's 2. What is the sum of all the numbers in the next row? It's 4, and then it's 8. That's suspicious. And then it's 16, and you can probably guess what the rest of them are, right? In fact, the nth row adds up to 2 to the power of n, right? So, row n, I suppose you could do segmentation or something, but I'm going to say adds up to 2 to the n. Huh. Did you expect that? that's a bit weirder. These ones, it's kind of like, well, duh. I mean, you can see why. But this is a bit, why is that? But yeah, but think about it. There are more properties, but these are kind of the important ones, right?